Welcome to the debate. Imagine unfolding a physical map of a city. You're trying to find your way around, but the moment your eyes linger on a coffee shop...
A whole map changes, right?
Exactly. All the roads leading to parks, or museums, or libraries, they just completely erase themselves from the paper. The ink literally shifts, leaving you with only this maze of streets that forces you directly toward the nearest espresso counter. Now, in the physical world, we would call that a nightmare of confinement.
Oh, absolutely.
But in modern digital architecture, we just call it optimization.
And that is a perfect metaphor for what we're tackling today. We're looking at the profound tension between artificial intelligence, system design, and, human autonomy.
Especially for the university students joining us. Those of you studying technology ethics, software engineering, UI design. This is really the defining architectural problem of your generation.
Right. So we are going to examine this collision through two distinct lenses. The mechanical, problem-solving perspective of a software engineer,
which is my side of things,
and the behavioral, structural perspective of a sociologist, which is where I stand.
So the central question we have to resolve is this. Is AI's behavioral mapping fundamentally a triumph of system design that brilliantly optimizes the user environment? Or
is it a structural mechanism that covertly confines human behavior and limits true autonomy?
Right. And from the system design perspective, my stance is that AI behavioral mapping is an incredibly advanced dynamic framework. It successfully reduces friction, by interpreting the millions of human traces we leave behind. It builds highly intuitive environments that genuinely serve our needs and cut through the digital noise.
Yeah, from the sociological perspective, while I concede that this engineered environment is brutally effective, its fundamental function actively shapes and narrows human choices.
Narrows? Come on.
Yes, narrows. It gradually substitutes algorithmic prediction for human agency. It creates an ecosystem where our autonomy isn't violently stripped away, but quietly, systematically eroded.
Let's get right into the mechanics of this, because I think this sociological critique often completely misunderstands what the system is actually doing on a technical level. Problem. The digital world is infinitely vast. Without a map, it is completely unnavigable.
Sure, but...
Wait, let me finish the thought. This map isn't a static demographic profile. It's not making assumptions just because you are 20 years old and live in a city. It is a living, dynamic model built directly from your actual data traces.
But those traces, every pause, every search, every click, they're just the raw material for something much more structural. You're describing observation, but the system definitely doesn't stop at observation.
Because observation alone doesn't solve the user's problem. At a scale no human analyst could ever manage, the algorithm takes thousands of micro behaviors and identifies clusters. Let's talk about how it actually does this. It places you in a high-dimensional vector space.
Right, the coordinates.
Exactly. Every action is a coordinate. The system calculates the mathematical distance between your behavior and the behavior of millions of others. It notes that the specific phrasing of your search query reveals urgency, or that the time of day you log on dictates your routine. It takes all of that empirical data to predict the next logical step in your journey. Ultimately, this predictive design combats decision fatigue. It creates a digital environment that anticipates what you need before you even have to ask. That is the holy grail of user-centric design.
The architecture is elegant. Absolutely. I'm not debating the math. But that elegance is exactly what makes it dangerous.
Dangerous?
Yes. You're describing a system that maps behavior, but it doesn't just passively reflect it. There is a critical difference between simply being seen by a system and being mapped by one. Being seen is a moment of neutral observation. Being mapped implies accumulation, structure, and active prediction that fundamentally alters the environment around you.
How is it altering the environment if it's literally just surfacing the exact things the user has mathematically demonstrated they want?
Because it is based on signals optimized for institutional goals, usually engagement, retention, or profit. When an algorithm is designed to keep you clicking, it narrows your world by constantly reinforcing familiar patterns. It creates a closed feedback loop.
Okay, but...
You respond to the system, and the system changes your environment based on that response to elicit more of that exact response.
This normalization of automatic behavior threatens autonomy because users begin to confuse a platform's predictive architecture with their own independent choices. They think they're navigating freely when in fact the menu of options has been entirely pre-selected for them.
But let's look at the function of the map itself. A geographic map doesn't force you to take a specific road, right?
Not a physical one, no.
Right, it simply illuminates the most efficient route based on where you've told it you want to go. If an algorithmic map just acts on your own behavioral signals, say you always compare product reviews before buying so it automatically surfaces reviews, why should that be viewed as a trap? It's an empirically driven reflection of your own preferences.
The geographic analogy falls apart the moment you look at how algorithmic weighting works. A geographic map is neutral topography. It shows you the 8-lane highway, the scenic coastal route, and the dead-end dirt road with equal clarity.
Okay.
An algorithmic map stops showing you alternatives once it learns what you are statistically most likely to click. It hides the dirt road entirely. It paves over the scenic route if it calculates that the highway maximizes your retention on the platform. Think of it not as a map, but as a digital architect that pours concrete over your footprint so you can never walk backward or sideways.
But if you never walk down the dirt road, why should the system clutter your interface with it?
Because you might want to one day.
If the user has demonstrated through their continuous behavior that they prefer the highway, the system is simply serving that preference. That is responsive design. You're assuming the system is hiding things maliciously, but it's actually filtering out irrelevant noise.
It's not about malice, it's about the structural outcome. When an algorithm learns your preferences too well, it prioritizes what keeps you active over what might challenge you or help you think freely. You are no longer looking at a map of the world, you are looking at a hyper-optimized map of your own reinforced comfort zone.
Which users like.
Confining users to a narrow corridor of familiarity traps them in a static version of their past behavior. The system cannot calculate values, contextual shifts, or personal growth. It only knows what you did yesterday.
Growth and context are incredibly difficult to quantify, sure, but behavior is empirical. The system designs the environment based on what you actually do, not what you idealize about yourself. And that brings us directly to the mechanism of how this environment is structured.
Friction reduction.
Yes, let's pause for a second. Because a student designing an app UI right now might be thinking, what's wrong with saving the user a few clicks? In software engineering, reducing friction is the core principle of good design. One-click purchases, autoplay videos, smart predictive text. These serve the user's universal desire for efficiency.
Wait, efficiency at what cost? When you make an action entirely frictionless, you are bypassing human deliberation.
You are bypassing cognitive overload. The modern digital environment presents an overwhelmingly complex array of choices every second. By making actions effortless, the system preserves the user's mental energy for decisions that actually matter.
That assumes they use that energy for something meaningful.
They often do. And this isn't just about consumerism or binge watching. Automated behavioral cues can actively enhance a user's life. AI systems remind people to sleep, prompt them to save money, and help them organize complex workflows. Reducing the decision fatigue associated with maintaining good habits is a net positive for human agency, not a detractor.
Let's break down the psychology of that, because the line between supporting a habit and hijacking one is razor thin. We know that behavioral psychology relies on the habit loop. Cue, action, reward.
Sure, basic psychology.
Right. A notification serves as the cue. The frictionless click is the action, and the dopamine of engagement is the reward. When you deploy that loop at a massive scale, billions of users, you aren't just saving people time, you are engineering environments that encourage impulsive, repetitive actions.
Which is exactly how human beings learn literally any habit, whether an AI is involved or not.
True, but human-driven habits usually have natural friction. If I want to read another chapter of a book, I have to physically turn the page. If I want to buy something in a store, I have to take out my wallet. Highly engineered digital environments remove that space entirely.
And that's a bad thing?
Yes. When a system makes it effortless to keep scrolling through sensational headlines or to purchase an item with zero friction, it trains people to accept automaticity. It weakens the fundamental cognitive habit of pausing and evaluating. You lose the space between impulse and action. We become reactive rather than proactive.
I have to push back hard on this idea that the system is forcing the user's hand. The autonomy to close the app, to put down the phone, or to step away still exists entirely within the user's control. The system just removes the artificial barriers to the actions the user has already demonstrated they want to take.
Does the autonomy really exist if the architecture itself is designed to make stepping away the path of highest resistance? Think about the asymmetry of choice architecture. If an autoplay feature immediately starts the next video before the credits even finish rolling,
It's just a convenience feature.
no, the friction isn't just removed from the system. The friction is removed from staying, while massive friction is added to leaving. You have to actively intervene, break a physical and cognitive momentum to stop the system. That is an architectural choice that dictates behavior.
But prediction, which is what autoplay and smart recommendations rely on, is the only thing making digital life manageable today. Let's look at the mechanism of reinforcement learning from human feedback. The system is constantly adjusting its weights based on what actually satisfies the user.
Satisfies or pacifies?
If a system accurately predicts your preference based on your own historical data, it is technically preserving your autonomy. It is serving your demonstrated interests without requiring you to manually sift through thousands of irrelevant options. You're framing prediction as a cage, but it's actually a filter.
It preserves the illusion of autonomy, perhaps. And this brings us to the core danger, the invisible institutional power behind those predictions. I reject the premise that prediction inherently preserves autonomy, because we have to look at who owns the model.
Okay.
When you are served a recommendation, it is not just your historical data at work. It is a mathematical model built by an institution to optimize for its own objectives.
But those objectives almost always align. A platform wants to retain attention, a user wants engaging content, a company wants to sell a relevant product, a user wants to find that product easily. Where is the conflict?
The alignment is entirely superficial, and the implications go far beyond consumer convenience. We're talking about predictive mapping deployed in workplaces, educational institutions, financial services, and public systems. The AI map affects who gets a loan, who gets flagged for managerial review, and who gets steered towards certain academic outcomes.
Well,
When a prediction is treated as objective reality, it buries the biases, the edge cases, and the institutional assumptions deep inside a black box.
That is a legitimate engineering challenge, I'll give you that. But it is an issue of optimization, not a fundamental flaw in the concept of mapping. If a map is inaccurate or built on biased historical data, it fails its primary function. Engineers are constantly working on the fairness and accuracy of these models, adjusting vector weights to prevent discriminatory clustering.
The danger isn't just a badly engineered map. The danger is that users and the institutions evaluating them begin to live inside these engineered maps as if they were reality. Let's look at a concrete example. A student in an algorithmic educational platform might be subtly steered away from a challenging topic because the system predicts they will struggle.
Based on their past performance,
Based on a cluster of past behavioral signals. Yeah, maybe they paused too long on previous test questions. The student never sees the advanced module. They trust the platform's architectural routing over their own curiosity.
but if the data shows a 90% dropout rate when students with that exact behavioral profile take the advanced module, isn't the system saving them from failure and keeping them engaged in learning?
It's enforcing a statistical average onto an individual life. It removes the opportunity for the student to struggle, to overcome, or to be the outlier. And the same happens in the workplace. A worker is evaluated by a model that measures their keystrokes, their response times, and prioritizes their tasks, subtly altering how they approach their job to satisfy the algorithm's metrics.
It's just efficiency tracking.
This is the sociological crisis. The institutional power to define the user mathematically supersedes the user's power to define themselves. You become a prisoner to your own past behavior because the system assumes your future will be a perfect replication of your past.
I recognize the risk there. Behavior is empirical, but it is not the whole person. An AI map captures massive tendencies, but human complexity and sudden, context-driven growth are notoriously difficult to vectorize. However, As an engineer, I argue the solution is better data literacy and more transparent design, not the dismantling of predictive mapping. Society needs a sharper understanding of how latent spaces work, what data is collected, and how profiles are mathematically built.
Transparency is nice in theory, sure.
Designers and developers must constantly ask themselves if their choice architecture is helping users navigate information or quietly dictating their path.
And we need to consider how much map-making power should belong to unaccountable institutions in the first place, especially when those maps dictate visibility, access, and social mobility. Transparency is a start, but structural power doesn't yield just because you can see how it works.
Let's synthesize this, because we've covered the technical and the structural dimensions deeply today. From the system design perspective, I maintain that AI behavioral mapping is an extraordinary technical achievement. It utilizes incredibly complex data signals to solve massive problems of scale. By creating intuitive, frictionless environments, these dynamic vector models reflect user behavior and serve our profound need for efficiency. They are the only viable compass we have to cut through the paralyzing noise of the digital age.
And from the sociological perspective, I maintain that this very efficiency is the mechanism of our confinement. It creates deeply entrenched dependency loops and prioritizes institutional optimization over human autonomy. By paving over alternatives and hiding the friction of choice, it replaces the messy, necessary complexity of human decision-making with the narrowness of algorithmic prediction.
Yet, despite our different lenses, we both land on a crucial point of convergence. Awareness is the ultimate form of resistance. Understanding the exact mechanics of how these systems weight your choices and structure your environment is absolutely essential for anyone interacting with them.
Precisely. To the university students studying technology, ethics, and design who are listening, your challenge is not to pretend we can stop AI mapping entirely. We can't put the genie back in the bottle. Your challenge as future architects is to figure out how to design systems where human choice remains visible and deliberate. We have to ensure that algorithmic maps do not become complete substitutes for human agency.
We must refuse to confuse a predictive vector model with our actual, evolving identity. We leave you with this delicate balance to weigh, the trade-off between systemic convenience and human autonomy. As you move through your digital environments today, remember the map. It isn't just showing you the roads anymore. It is rapidly building the roads under your feet as you walk.
The question is, are you still the one choosing the destination?